Hello everyone. Today we are going to talk about what homoscedasticity is. Now everybody is aware of what linear regression is and why it is very pervasive in the industry, and many people incorporate linear regression models in their model building exercises or to solve business problems. Now, linear regression has a lot of assumptions that is backing it in order to make it more effective when it is being incorporated or used to identify or predict the values. Now, some of these assumptions are something that you verify with the data, and some of these assumptions are something that you verify after building the model. So, the assumptions that you verify after building the model helps us understand how effective the model that we have built is, right? So some of the assumptions that we can check before building the model is collinearity, linear relationship, and autocorrelation. Now, collinearity basically tells us what is the strength of relationship between, or quantifies the strength of the relationship between the dependent and the independent variable. Linear relationship tells us if they are linearly related with each other, and collinearity and linear relationship also goes in hand. And autocorrelation tells us that if a certain data point is being considered to build the model, if the data points that come before it or after it, is there any influence on the data point that we are looking at? So these are some of the things that we can verify from the data itself, but there are some of the assumptions that we'll have to see after building the model. That is, after we get the predicted values. Those two are homoscedasticity, and the other one is the distribution of the errors. So we need to look at a histogram of the errors that we've got after building the model and make sure that it is centered around zero and not widely spread, so that we do not end up with some of the error terms with very high values, so that the model can be understood as predicting values that are closer to the actual values. Now, coming to the topic that we are going to see in this video, homoscedasticity, it basically tells us if the error terms is having constant variance or not. By this, what it says is that the dependent variable and the independent variable, as their values increases, the errors should not increase. Let's take a simple example in order to understand what this actually is in the next slide. So here we have two models, model 1 and model 2. It shows the independent variable x, the dependent variable y, the predicted variable y dash, and the error terms. Now we also have a distribution of y values, which are our actual values, and y dash, which we are getting from a regress line. Similarly, in model 2, we have the independent variable, predicted values, and the error terms. As you can see, in the first model, x varies from 1 to 8 and values of y varies from 1 to 64. But the predicted values only vary from 2 to 16. Sometimes, if you look at the errors, it is in the first record especially, the predicted value is higher than y. But if you look at the last record, the predicted value becomes very less compared to the actual value. So as the value of x increases and as the value of y increases, the gap between the regressed line and the actual values is also increasing. So this is a model that cannot be classified as a good model, because we are seeing only a snapshot of the data, but as the values increases, this distance only continues to grow, and the predictions that this model make cannot be relied upon. If you see model 2, the scenario is sort of better. Despite not having a very accurate prediction, it is able to generalize whatever pattern that is present in the data. Now we have the same values of x, we have the same values of y in both these tables. Now the predicted value y dash is better than what we are seeing here if we look at the errors. Now if you see, the errors are ranging from 6, maximum value is -8, a minimum value as -8 to maximum value of 12. But it is slightly bound in a certain region and there is no variance. There is no lot of disruption that we are seeing in the values. So the variance is somewhat same in all of these values that we are looking at. So this basically tells us that even if the values of x and y increases, the regress line will also increase proportionately. So there won't be any incremental gaps between the predicted values and the actual values. So this is what homoscedasticity tells us to check and helps us understand if a model is performing better or not. Thanks for looking at the video.